So now that we've talked about the splitterators, which are really what produces the stream, let's start talking about other elements of the stream. And again, I've talked about some of these things in general, but I want to go through them in more detail now. The first thing we're going to talk about are aggregate operations, and then we'll talk about what aggregate operations are composed of, which are intermediate operations and terminal operations. So I think I mentioned before, an aggregate operation is a higher order function that applies the behavior to elements in a stream. And a higher order function is just a fancy name for a function that is passed a function as a parameter. So in our world, the aggregate operations are functions, and they're passed these behaviors. The behaviors, of course, will be lambdas or method references to various types of functional interfaces like function, predicate, supplier, consumer, bifunction, blah, 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 all those kinds of things. Kind of as we talked about before, aggregate operations are yet another incarnation of the coolness of functional programming, where we focus on the what rather than the how. So if you think about the functional programming foundational elements we talked about before, method references and so on, that gave us the core concepts, and then streams are just kind of composing these concepts together in a more flexible way, so that's good. There are two types of aggregate operations. There are intermediate and terminal operations. Intermediate operations, as the name sort of implies, appear after we get the input from some source, but before we reach the end of the stream. So they're kind of the things that are intermediate. And what they do is they process the elements that come from their input stream, and they yield an output stream. So that's the way to remember whether something's an intermediate operation or something else, is whether it will take an input stream and then return an output stream, or return a stream that's an output stream. And there's a bunch of examples. We'll talk about a lot of these things: filter, map, flat map, take while, drop while, and so on and so forth. You don't actually have to have intermediate operations in a stream. It's perfectly acceptable, though not particularly common, to just go directly from creating a stream from some source, like, say, a collection of some type or an array, and then going directly to a terminal operation. Not common, but it's certainly possible to do it, and we'll show some examples later where it might be useful. Okay, so that's the basic idea. You can classify intermediate operations according to several different dimensions, and I show them in this little table. So the dimensions are stateful and stateless, and run to completion versus short-circuiting. So those are the elements in this fourfold table. So stateful operations, stateful intermediate operations, are going to require state from prior invocations to use in future incarnations. So a good example, probably the best example, would be the sorted method. Obviously, if you're going to sort something, you have to have all the other input that has come in through the stream before you can sort it. It doesn't do any good to sort the items sort of in isolation from each other, because they have to be sorted together. So that's one example. There's another thing called distinct. Distinct says only return the elements that are not duplicates. So if there's multiple copies of something, only give one copy of those multiple copies, or one element, not a copy. That, of course, requires seeing other things to know what duplicates there are. So there's a bunch of examples of things that are stateful. And as you'll see later, stateful operations have some overhead associated with them that make them a bit more complicated to implement and maybe make them a little slower. But they can be very useful, of course, because they do useful things for you. There's also a set of stateless operations, stateless intermediate operations. And these are operations that don't require or don't store any information or any state from any prior invocations. They do all their work on each element one at a time in isolation. So examples would be filter, map, flat map, and so on and so forth. Then another dimension, so stateful, stateless are kind of the rows, and then the columns would be run to completion and short-circuiting. Run to completion, which hopefully makes intuitive sense, says take every element and process them until you're done. So it runs them all until they're finished. Conversely, there's also short-circuited operations. And these operations may terminate without looking at everything in the stream. And so they typically take in some kind of expression or condition and will only go that far. They only go as far as they need to, so they short circuit. So a good example would be limit, where you're going to say, I only want to process the first n elements in the stream. And after the nth element, I don't want to process anything more. Then there's also some other ones we're going to talk about called take while and drop while, and we'll look at those. Those also have conditions that they use to decide how far they're going to process the stream. So those are the intermediate operations. Then there's a lot of them that are fun, and you'll get a chance to program all this stuff. And in fact, your current assignment gives you a chance to use operations like filter and map and so on. So you get a chance to do that. Then there's also terminal operations, and these are the ones that occur at the end of the stream. Can only be one of them, and they do two things. They trigger the intermediate operations because everything is lazy, as we'll see over and over again, and they produce a non-stream result. So that's the way to, when you look at the streams interface, which has a lot of methods in it, you go, which ones are intermediate, which ones are terminal? If the return value of an operation is not going to be a stream, then it's probably a terminal operation. And those would include things like for each, reduce, collect, find any, and so on and so forth. Once again, there can only be one terminal operation, and you absolutely have to have it in the stream, otherwise it won't do anything. I should point out, this is a good side note here, for your programming assignment 2A, make sure that in the method that does the image processing, I think it's process image or something like that, in that one you have to basically get the image and then go through all the transforms and apply the transforms to the image. For that method, make sure that you filter out any null images. And the test program actually intentionally injects some null images to see what your program does. So if null images come into your, null images would occur if you try to download an image that doesn't have a matching URL, though the URL is wrong, or the server is not reachable, or whatever. And the test program will generate some of those just to see what your program does. Make sure that you filter out null images, or null values that represent null images that didn't download properly or transform properly. And so you'll have to sort of figure out how to do that. I'll give you a hint. It uses a filter to do that. OK, so once again, you can classify terminal operations according to several dimensions. You can have the operation type to be either run to completion or short-circuiting, just like we did for the intermediate operations. So they don't have stateful, stateless, but they have run to completion and short-circuiting. And as you can see here, run to completion, those are the ones we're going to work with quite a bit in this course. Reduce, collect, for each. Those terminate only after all the elements in the stream have been processed. And then conversely, we also have a bunch of short-circuiting operations, like all match, any match, find any, find first, none match. And these may not have to terminate, may not have to process all the values before they terminate. For example, if you use find first, the first one you find, you're done. Likewise, all match, the first match that doesn't match, you're done, and so on and so forth. So those are examples of short-circuiting terminal operations. So that was our quick overview of aggregate operations.